which of the following equations is correct, right? Which following equation is correct? Now, you see this triangle down here at right hand side, right? In one of the notes, right? One of the slide, you will see this triangle. V represent voltage, I represent current, and R represent resistance. So very easy for you to remember Ohm's law, right? V, you wrote V, right? The below you have I and R, so I times R, right? So voltage equals to current multiplied by resistance. Now, if you want I, the formula for I, right? You have I, you write I equals, what is left right now will be V over R. Do you see? V over R, right? So is current equals to voltage over resistance. Alright, if you want R, you write R equals what? You cover the R, you are left with V over I, right? V over I. So resistance is actually equal to voltage over current. Now, so what is the correct answer? The correct answer, of course, is resistance equal to voltage divided by current. Now, resistance down here, right? Resistance. So if you cover resistance, cover up. Oops. Okay. Cover up resistance. What is left is actually your voltage divided by current. Do you see the one line out here? Right, divided by resistance. Okay, let's go on to the second one. Right, second question. Second question. Okay. Which of the following is the best description of current? Now remember I tell you show you all the electrical charges down here. Electrical charges. Current is a measure of how fast your electrical charges flow through the circuit, right? So current describe the energy in a circuit. Now energy is definitely not current. Energy a better I think voltage, right, will better describe the energy rather than current, right? Current is the flow of electrical charges. Current is a force. The force, again, force, voltage is a more suitable word for force. All right. Current is the flow of charged particles. Yeah. Basically, current is the flow of electrons. All right. Flow of electrons. And it measures how fast they flow. All right. The faster they flow, the higher the current. Question number 3. Which of the following is a unit for resistance? Of course, the ohms, right? This one no need to think, ohms, right? Number 4, what is the unit for current? Of course, ampere, right? Amps. Voltage is volt, ohms is for resistance, all right? Number 5, this one you need to do a little bit of thinking, all right? A little bit of thinking down here. Now, the resistance as a cross-sectional area, right, of a wire increases, how will it affect the resistance? You look at its wire, right, thin one, right? So cross-section area will be smaller, bigger, right? Cross-sectional area is bigger. Or if you can see the dots, you see many dots down here. If each dots down here represent one strand of wire, of course this one will have more strands of wire, right? More strands of wire. More strands of wire, that means what? More electrons can flow through, right? It can flow through easily, correct or not? Because you have more strands for the electrical charges to flow. This one have less strands, all right? So the bigger the surface area, the lower the resistance. Because it will make it easier to flow. All right. You can just think about it as a bigger pipe, right? Bigger pipe, a smaller pipe. All right. So resistance will become will stay the same. Now increases in cross sectional area cannot be the same. Resistance will decrease, right? Resistance will decrease. So this is the answer. cross-sectional area does not affect resistance, right? This is wrong. Resistance will increase. This is even worse, right? Now, question number 6. Why does an increase in cross-sectional area decreases resistance? This one I've just explained. The current has a larger surface to pass through. Alright? It cannot be less space to pass through. See or not? Bigger surface area, you have more space to pass through. Alright? So let's move on to question number 7. Now, which arrangement, right? Which arrangement will give you the highest resistance? Now, they tell you all the resistors are identical. That means the value of the resistors are the same. Their resistance are the same. What is this type of connection called? Now, if you remember carefully, if you can remember, right? This type of connection we call them the series connection, right? Series, right? Series. Why do I say that it is connected in series? Series means one after another, right? One after another. Current have to flow through here. After that, flow through here and then flow through here. Alright, current have to flow through, overcome the first resistor, overcome the second one, and then overcome the third one. Give you an analogy, your class, right? Everybody in your class is here. Then your PE teacher asks you to do 3 station. Go through 1 station, 2 station, and 3 station. Okay? Okay, the 3 station represent your resistance. I represent the resistor down here. Now, if I have every station, you come here, the first station, you have to do 10 push up. The second one, also do another 10 push up. The third one, the third station, also you do another 10 push up. Alright? Every resistor down here is represented by 1 station. Now, your class, you are to do 1 by 1. The first person come here, do 10 push up. After that, you move on to the second station, do another 10. Now, the second person move here. The first person move here, yeah, the second person can move here. The third, you finish the second one, second station, move down here. So how long do you think now it's going to take your whole class some time to complete all the 3 stations until the last person, right? Until you move everybody down here, right? You people down here represent what? The electrons, the charge, right? What you call the charged particles. Now, by the time everybody move here, right, how many people in your class? Maybe 30 lah. All the 30 of you all finish all the 3 stations, it's going to take you a long time. Correct not? Because you have to do 1 by 1. Now, you cannot have people what you call two person doing at the same time. Alright, one person do one time. So now, this type of connection, right? The resistance will add up. Alright, so the resistance for this is actually highest. Now you imagine now I rearrange if I'm your PE teacher, I rearrange the station to become like that. Alright, so when you start, or you have 30 fella down here, when you start, I want to bring everybody down here, same thing, 10 push up, 10 push up, 10 push up. Now, but then once I blow the whistle, 2 of you can start together, 1 down here and 1 down here. When this fella finish, he will have to come here and do another 10. Whereas this person finish already, straight away come to the pool here. You will finish this configuration faster, right? I think the 30 of you finish faster because why? Now you only have to do 10 and then 10 finish, or some of you only do 10 down here, right? You will finish faster. Alright, now the connection down here is a mixture of series and parallel. Now why do I say it's a mixture of series and parallel? The two resistors that are connected this way, alright, these two are connected in series. Alright, these two are connected in series where this one is in parallel with this branch. Alright, it's in parallel with this branch. Now, for example, if let's say this is 10 ohms and this is 10 ohms, this is another 10 ohms. Now, I can represent this thing 10 ohms plus 10 ohms become 20 ohms. Now, it will actually become like that. Alright, what the current will see is this one branch have a resistance of 20 ohms, another branch having a resistance of 10 ohms, right? So I have 10 ohms in parallel with 20 ohms. Now that is for that is this one. So of course, if you compare this configuration, if you compare this configuration with just now this one, 10, 10 and 10, of course, who will have a bigger higher resistance? Of course this one, because this one is 10 plus 10 plus 10. Alright, whereas this one is a 10 ohms in parallel with 20 ohms. Now if you can remember, alright, if you can remember, resistors connected in parallel, right? Resistors connected in this manner. Now the effective resistance between this point and this point, right, will be lower than the smallest of any branch down here. That means for this, that is to say for this configuration, you can very safely say that the effective resistance between point A and point B is lower than 10 ohms, right? It will be lower than 10 ohms, right? Because if I only have a 10 ohm branch, right? If I don't have this branch, imagine I take away the 20, right? The resistance between A and B will be 10 ohms. Now I add another branch for the current to flow, 20 ohms down here. Now, initially I only have one path. Now I have another path. Alright, although it is not going to flow as fast as this branch here, but however, you are still having another path. It's still helping the current to flow faster. Current to flow faster from point A to point B. Alright, which is why we say that the overall resistance is lower than 10. Alright, will be lower than 10 ohms. Alright, now this one, the third one, alright, all the three resistors are connected in parallel. Now this one will give you the lowest resistance. Now imagine just now alright, you imagine just now you have 3 stations connected like that. Every one of you is going to do 10 push up, 10 push up, 10 push up. But now if now I'm your PE teacher, I set up another 3 station, right? 3 station will be like that. Right, 10 push up, 10 push up, 10 push up. Now this is the end point. Right, this is the end point. Every one of you have to come here. Right, all of you are here. Right, you look at, now you have 30 of you here. Now you look at as long as I blow the whistle. Once I blow the whistle, down here nobody doing the push up, you come over here, you do. Right, so you have 3 person. The moment I blow the whistle, 3 of you can do together. Do 10 only, do 10. Do already, straight away come over here. Right, so you will, what you call, all of you will be able to clear off, right? Will be able to clear very fast. Because why? 3 of you will do together at one time, right? At the same time, right? And then I'm assuming that all of you will do 10 push up and run over here in the same amount of time. Alright, all of you are equally fit. Alright, so if you compare this, right, to this, right, down here is very much higher, right? This one is very this configuration is very much lower, right? The resistance down here is equal to what? If you have 10 ohms, 10 ohm, 10 ohm, 10 ohms, it will be a total of 30 ohms down here. For this one will be what? 10 ohms divided by 3. I have these two in parallel, right? These two is in parallel, and then in series with another 10 ohms, right? And in series with another 10 ohms. Now, how do you work out the resistance in this case, alright, I have this. For example, this is 10 ohms. You can see, I branch out. I have 10 and I have 10. Now I know that these two in parallel, right? And in parallel, the resistance will be lower, correct or not? Will be lower because I provide another branch for the current to flow. So 10 ohms in parallel with 10 ohms, what do you get? You get 10 ohms divided by 2. So this branch down here, alright, you know that the resistance is definitely lower than 10. So you have 10 ohms down here. This 10 ohms is actually connected in series with this branch, right? 10 ohms here is connected in series with this branch. So how many ohms down here? 10 ohms divided by 2, so you have 5 ohms. So effective resistance down here of this configuration is actually 10 plus 5, alright, 15 ohms. Alright, 15 ohms. So who will give you the highest? Of course, the highest is here. Alright, highest is here. Which one give you the lowest? Which one give you the lowest? Lowest is, of course, this one, because you have 3 branches. Number 9. Okay, like that. Which one will have the highest current flowing through it? Highest current. Now you can see that all these are in parallel. 3 volts applied across all the resistors. Is there any splitting of voltages? There's no splitting of voltage. No splitting because now take a look at the terminals. They are all connected directly to the battery. Alright. Current doesn't need to flow through one resistor after another, right? Current will have to can flow through all these together. So you can see that 3 volts is applied uniformly across the 4 resistors. Alright, so in this case, since we have the Ohm's law, what is the Ohm's law? Can you remember current I represent with I is actually equals to voltage divided by resistance. Alright, current equals to voltage over resistance. So if my resistance is high, right, my resistance is high, my current becomes more, alright, because my voltage is the same. The current through this is 3 volts divided by 2, 3 volts divided by 4, 3 volts divided by 6, and 3 volts divided by 8 ohms, right? So this is 1.5 amp, the first one. This is only 3/4 amps, and as you go higher, the resistance increase, you have lower current, right? So of course the current, the highest current, the resistors with the highest current is of course the 2 ohms resistor, right? The 2 ohm resistor. Okay, which resistor down here? Okay, which resistor down here will give you the higher voltage? Has a higher voltage across it. Now 5 volts. Now 5 volts, 5 volts, this is different. 5 volts is shared, right? 5 volts is shared among the two. See, current have to flow through one and then flow through the second one before it gets back to the battery. 5 volts down here is shared among the 2 ohms and the 3 ohms, right? 2 ohms and the 3 ohms. Now, so who get a higher voltage? Who has a higher voltage? Now, all you need to know right now is this, for resistors connected in series, alright, they share this voltage, they share a 5 volts voltage. Now, the 5 volts will be shared in proportion to their value of resistance, right? The bigger the resistance, the bigger one will take a bigger portion. So for example, 3 volts, I have 3 parts. Out of the 5, the total is 5 ohms, right? So your 3 is bigger, so 3 will get 3 volts. 2 will get the remaining 2 volts. Alright? Okay, this one voltage divider, how to calculate a voltage, next lesson then we do, right? So much for now. Alright, we carry on, go through